All right, good morning. Thank you for coming. I'm Daniel Rogers with Duo Tech Services, and I'm going to talk to you a little bit today about radar warning receiver and some upgrade and sustainment options that go along with that. Now, what Duo Tech does is repair, reverse engineering, and redesign for military electronics and electromechanical systems. So what we're going to do is take you through some of our capabilities and how they apply to working through some of the obsolescence issues, especially with the ALR 4656M and the ALR 69. So, in looking at that, we see that there are a lot of issues when it comes to dealing with the sustainment, particularly because of component obsolescence in the ALR 69, 46, and 56M. We also see that many customers still want to operate the existing system. Now, wanting to operate the existing system and not having the capability to maintain it is really the space that Duo Tech works in order to provide the sustainment, repair, and then in going forward when something can absolutely not be maintained anymore, taking that next step. So because of the lack of support for sustainment and upgrades to these radar warning receivers, that's how Duo Tech has come in and worked to provide some solutions in that space. So what we're looking to do is to sustain the current system and also provide a replacement along with supportability options in moving forward that are not only available but are also affordable. That is something that it comes down to, where there are upgrade options, but providing one that is affordable is our solution, and providing that long-term sustainment that goes along with that affordable option in the end is what we would like to show off here. Now, with the current radar warning receiver, we have capabilities when it comes to repair, but in moving forward, providing something that has greater capabilities that leverages the current existing technology is what we are providing. Not only does this have the advantage of providing some more up-to-date capabilities, but also when you're dealing with a lot more modern technology, you get a lot higher performance for a much lower cost. So we're looking to do this in such a way that provides minimal modification of the aircraft, providing nothing that has to be done as far as changing of software and firmware in the current aircraft, and providing a path forward for maximum sustainability. We want to provide a solution that allows us going forward to be able to sustain a solution in repair and support in the long term, so that this does not become a continuing ongoing problem when it comes to supporting the radar warning receiver. So as part of that, what we're doing is we are looking at the full scope of it, not just providing, okay, well, here's a part you plug in, you go from here, and it moves you on, but being able to go with the operational requirements of the user, being able to support them when it comes to documentation, repair, support, logistics, and all that goes into providing sustainment for a system such as this. So what we're looking at here, as it shows, is the ALR 69, but also applies itself to the 46 and 56M flying in the F16. And that's what this upgrade's about. So here, looking at the current system, what we are looking to do is to provide instantaneous bandwidth from 2 to 18 gigahertz and solve a lot of the logistical and the DMS issues going along with the current ALR 69. So what we're going to do is, or what we are doing is, we're providing what is required to move through the obsolescence issues, especially when it comes to a lot of the RF components in the ALR 69. And the key to providing something that is not only long-term sustainable and supportable, but is as low an impact on the end user as possible, is something that has minimal installation and modification requirements, and something that operates seamlessly with the existing system. So we don't want to provide a solution that is untenable either through effort or acquisition cost when it comes to a solution for the end user. So those are things that are at the core of what we are interested in providing. So what does this actually look like? It's all well and good to say that we have new technology, we have a new approach, and there are many things when it comes to doing ultra-wideband data conversion and dealing with digital signal processing. But also showing that, being able to characterize the system before and after, dealing with a lot of issues in the system, not just saying, okay, we have an RF front end that provides us better sensitivity, but also being able to baseline aircraft before and after, being able to see the actual before and after when it comes to what sort of sensitivity and threats can be detected. So that's really the jumping off point for where do we go with this system. From there is we're looking to provide a system that not only has that instantaneous bandwidth capability, but it also has the ability to deal with much weaker and much narrower pulses than are currently available are being able to be measured in the current system. Being able to do that is where the modern, newer, upgraded technology comes into play, being able to deal with lower level pulses, as well as being able to deal with narrower pulse trains. So what this looks like is, it looks like dealing with the amplifier detectors, the onboard power supply for the signal processor, as well as the signal processor itself. So this is not a function of replacement of antennas or wiring or things like that. This is a function of the actual amplifier detectors themselves, the signal processor, as well as the replacement of some power supply to feed that that upgraded signal processor as well. There are some great solutions being provided now by a lot of silicon manufacturers that allow us to deal with much of the upgraded technological requirements. It used to be that when you're talking about dealing with ultra wide band, you'd be dealing with, okay, maybe 100 megahertz, maybe 500 megahertz of bandwidth. But in something like this, being able to use some of the newer direct conversion technologies, being able to deal with an instantaneous bandwidth of 2 to 18 gigahertz, especially getting down in that lower end and dealing with some of those muddier areas that are often clouded by cellular and other signals, is what we're able to leverage with some of the new signal processing capabilities and technologies that exist. So this right here shows off kind of what it actually looks like. So what it is replacement of these, as well as dealing with the signal processor and the power supply there for it. So I'll back up a little bit so you can see the old one and the new one here in this. So you can see the change there from where you see where it was yellow is now in the white section here. So dealing with the amplifier detector portion as well as the signal processor is what we're actually after here. So what does this actually mean? So we're after improving the situational awareness and the cockpit resource management of the pilot, being able to provide a system that not only gives them better technical specifications, but really, if you're thinking about it from the perspective of the warfighter, of the pilot, giving them the ability to detect threats farther off at longer ranges sooner. There's enough going on in the cockpit of an aircraft when it comes to dealing with the actual operation of the aircraft, dealing with the actual performance and the actual operation of the power plant, navigation, everything else that has to be dealt with in navigating airspace, but giving them the ability to detect and identify threats sooner. Not only be able to identify threats sooner, but through modern signal processing technology, being able to detect and weed out false alarms. That's really one of the keys here, is having an underlying signal processing architecture that allows us to get rid of a great deal more false alarms. Just like when it comes to a radar system, you don't want false bug targets. In the radar warning receiver, you want to be able to weed out as many obviously and potentially false targets as possible to maximize the attention of the pilot on the things that matter coming up. So beyond that, being able to increase detection range really by double with this capability, and dealing with the probability of detection of both weak and narrow pulses. That being done through, rather than having a traditional swept type RF architecture, but being able to deal with, measure, capture, and define those threats and bring them in all in one large instantaneous bandwidth look, as opposed to dealing with some of the swept time domain multiplexing conversions that happened with older systems. So this replaces old components and this improves the sustainability of the system. So we're getting rid of older technologies, replacing them in a modular, standards-based fashion, and providing a solution going forward that provides not only being able to get components, but supportability for a system that has not been supportable for a while. So what this is, this radar warning receiver is providing a solution that has been in need for a while, and there are options for upgrade that come at a very great cost. So what we're looking to do is not provide something that takes away the current paradigm of the guy, the boots in the ground, the one that has all the knowledge and understanding of how to do current repairs, but also getting rid of the need to deal with a lot of the upgrade requirements when it comes to having to upgrade other components of the system and avionics and software and OFPs that go along with that. So what we're looking to do is provide a long-term sustainment option that is both easy and effective. Providing this at a low cost is key, and Duotech has been doing that now for about 33 years, providing solutions whenever the current options have not been tenable, providing those solutions that let hardware be flown longer at the price point the customer is looking for. Now, as far as questions when it comes to this, I want to put this offer out there. Please do contact me. My name is Daniel Rogers. I'm the Vice President of Duotech Services. If you have any technical questions, anything that comes up from a business case, please feel free to call me. I don't know what the accessibility is to other people that are vendoring this, other vice presidents, but this is my home phone number, 828-421-2342. Call me anytime, 24/7, 365 days a year. Again, Daniel Rogers, 828-421-2342. Thank you for your time.